Now, let's draw a spur gear profile with the approximation method. But before we start, let's talk about a few terms of a gear. Let's first know about the four circles of a gear. First, we have the addendum circle, or the outer circle, which is the outer circle touching the outermost points of the teeth. Then, we have the pitch circle. When two matching gears mate, they move as if they were rollers of the pitch circle without slipping. Then we have the base circle, which is the circle in which the involute tooth profile or the tooth curve is developed. Finally, we have the dedendum circle, which is the circle touching the bottom of the tooth profile. When two matching gears mate, their point of contact moves along the line of action. They're constantly changing and they move along their line of action when they turn. The angle between the tangent of the touching point and the line of action is called the pressure angle. There are two important base parameters when determining a spur gear profile. First is the module, which is the diameter of the pitch circle over the number of teeth. This determines the size of tooth. Then we have the pressure angle, which is usually 14.5 degrees or 20 degrees. One important thing is, gears will only work together if the module and the pressure angle is equal. Now, let's crunch some numbers. These are the numbers we need to know when we're drawing a gear profile. First is the module, is self-determined. Larger value usually equates to larger tooth. Then we have the pressure angle, which is self-determined, usually 20 degrees or 14.5 degrees. Then the pitch circle radius, as for the definition of the module, is the module times the number of tooths. This will give us its diameter, and then we divide it by 2. For the outer circle or addendum circle, we usually add one module to it. This is by standard. For the inner circle or the dedendum circle, the radius is usually 1.25 of the module. This is also by standard. For the base circle, it is the pitch circle radius times the cosine of the pressure angle. And for the approximation method, we also need to know the pitch circular thickness, which represents how many degrees is that tooth going to be responsible for the contact. This is calculated by 360 degrees divided by 2 times of the number of tooths, because there's an equal amount of tooths and spaces. So let's start drawing. So let's make a gear with these parameters. First, we draw the 4 circles. So we draw 4 circles. And we'll dimension it from the inner circle, which is a 16.88. Then the base circle, 17.62. The pitch circle, 18.75. And the outer circle, which is 20.25. Now, we'll draw a vertical line from the circle center. We'll also draw a thickness reference and a pressure reference, like this. Angular relationship between the vertical line and the thickness reference is half of the pitch circular thickness, as we are drawing half of the tooth profile. And between the thickness reference and the pressure reference, this should be the pressure angle, which is 20 degrees. Now, we'll find 2 intersection points. We'll find the intersection between the thickness reference and the pitch circle, and the intersection between the pressure reference and the base circle. Draw a line to connect these 2 points, and draw a circle from the base circle intersection to the pitch circle intersection. On the left side of the vertical line between the inner circle and outer circle is part of our tooth profile. We could erase the redundant lines. And this is half of our profile done. To get the other half, we could just mirror it along the vertical line like this. Okay, so let's constrain it. Put this on the line and put this on the line. These two should be equal, and this should be symmetric. So let's see. So these two should be equal, and these two should be symmetric. Now we're fully constrained, and we could remove parts of the inner circle and outer circle to make it a closed sketch. So we'll cut this and this. Trim away these parts. Okay, so now we can also do a fillet between the tooth profile and the inner circle. Like this. So let's make these equal. Let's do a 0.5 millimeters fillet. And let's see. So we'll make these points symmetric. Now we're fully defined. Let's make some of our lines reference lines so that it won't interfere with our solid process. So these are all reference lines. Now, we could just extrude it or pad it and do a circular array. In this case, we have 25 tubes, so we enter 25 along. So we rotate it with 25 occurrences. We'll wait for it to compute, and this is our gear done. We've successfully made an approximation of a spur gear. Thank you.